Okay, so we have a bar who has a smooth contact on this roller and on the wall. And we have a force P that is applied at the end of the bar that is equal to 600 Newton. And the question is, what is the force between the roller, let's call this N, and the rods, and the distance A that is unknown? What is the distance required for equilibrium? Okay. And we have another force from the wall that is the normal force from the wall. Because that's smooth contact, there is no friction force. So just a normal force. And remember that a normal force is always normal to the surface. It doesn't depend of if it's a wall or if it's the body. It depends which one is flat. So this flat surface is the wall, and its flat surface is the road. Okay. So if we look at this equation, and what we don't know is A. We have 3 unknown. Okay, we don't need to solve for all of them. We need to solve for N and for A. So which equation should we take? If we do the force on, if we use this axis X and Y, okay, and we use the sum of the force on the Y, we will not have the normal force from the wall, and we don't need it. So let's do sum of the forces on the Y axis equals 0. So we need to find the complement of the normal force on Y. So we have an angle 30 degrees. So we have 60, so we have 30 degrees there, right? So if we look at this one, what we want is the vertical complement. So we have cosine 30 that is equal to the complement on Y divided by N. Okay, so the NY equal cosine 30 times N. Okay, so let's do sum of the forces on Y equals 0. We have cosine 30 times N minus P equals 0. So we got N that is equal to P, this 600, divided by cosine 30. We got N, that is twice, oh, not twice, 692.8, so 693 Newton for N. And now the second question is, what is A? Okay, so A is a distance. So we have to solve with the moment. That's the only formula that included distance. And we want to avoid to solve for NW. We can now. It's just the N sine 30, right? Just N sine 30 for NW. But if we use the point, this one, let's call this point A, and we do the sum of the moment about A, we don't even have to find NW. So let's do sum of the moment about the point A equals 0. Okay, so what do we have? For N, so we need this distance for N, we need this one, right? The perpendicular distance. Let's call this distance, I don't know, B. So if we look at this little triangle, we have cosine 30, that is equal to the adjacent side, that is A, divided by B. So we have B, that is A, divided by cosine 30. Okay, so that's the distance B. And for the distance for P, what we need is the complement P on parallel and perpendicular to the road to multiply by D, so that this one, and we have the 30 degrees, this one that is the same than this one, right? So that's give us P cosine 30 degrees times D. Okay, so sum of the moment about A, we say that the normal force N tend to rotate in a positive direction, so plus N times the distance B, that is A divided by cosine 30. And P tend to rotate in the negative directions, but the only complement that tend to rotate is this one, perpendicular to the road, so minus P cosine 30, and time the distance D equals 0. and the only unknown there is A. So we have, let's replace everything. N is 693 divided by cosine 30 times A, and it's equal to P, that is 600, cosine 30, D is 1. So we ended up having 600 divided by 693, and we have cosine 30 squared. We have A, that is equal to 600, times cosine 30 times cosine 30, and divided by 693. That's 0.65649, 0.649 meter. Okay, so that's a little bit more, this ruler should be a little bit more to the right. At the end, it's like, because D is equal to 1, and you see 665, so probably the ruler will be there. Otherwise, it will fall, it will slip. There we go. So answer, the distance is 0.665 meter, 65 centimeter, and the normal force between the cylinder, that's a ruler, but let's say more cylinder, and the rod N, this one is 693. So we solve for those two unknowns. See you in the following video. Bye bye.